Hey, welcome back to the lecture. So in this lecture, what we're going to do is we're going to see practically how a user button delivers its interrupt to the processor and how exactly our interrupt handler gets executed. And once you understand that, the mechanism can be applied to any microcontroller you have at your hand. Now let's get started without wasting any time, and I'll be doing this experiment on my STM32F4 discovery board, and you can also try it on your board. So now what I do is I first open the user manual, and I just go to the schematic at the end in order to know how exactly my user button is connected to the microcontroller, because without understanding that, you don't know how actually user button interacts with the microcontroller. So here it is, user and wake up button. Alright, so if you observe this button carefully, okay, so this button is actually connected to GPIO port A 0th pin. So that we can see here in the microcontroller. If you go up, this is a microcontroller, and PA0, this one, PA0, so which happens to be the 23rd pin of the microcontroller. So your button is connected over here, PA0. all right, and this capacitor is not present. That means this is open here. And when you push the button, what happens when you push the button? So the VDD connects to this point here, right? So but here you can see that it's actually a voltage divider circuit where this is of higher resistance, 220k, compared to a small resistance here. So that means the PA0 is almost like pulled to high, right? If you close this button, and if you release this button, then it's like pulling this PA0 pin to the ground. So that means if you push the button, the PA0 pin is pulled to high, and if you release the button, the PA0 is actually pulled to ground. So now our goal is, when I push this button, I should get an interrupt in my application. So let's see how we can do that. Great. So before going to the implementation part, we have to understand so many things related to this small task. Alright, so now we have to understand how GPIO pin interrupts the processor. That means, what's the design? So you have to understand the design. The design means how the vendor delivers the GPIO interrupt to the processor. Okay, because it is highly dependent on the vendor. Because you already know that somehow all the interrupts must come to NVIC, but the way they deliver to the NVIC is different. So that we have to understand. The design we have to understand. Alright, so now I would like to take you to the reference manual of the microcontroller. So here, open the section called Interrupts and Events. Just open that, and under that, open the section External Interrupt and Event Controller. And under that, just open External Interrupt Event Line Mapping. Great, yes, this is the one we wanted. So now what I'm going to say is specific to ST. So the ST microcontroller has a engine called EXTI. They call it as External Interrupt Controller. So if you want to see how that looks like, you can click on the EXTI block diagram. Okay, so the EXTI engine looks something like this. So here, so let's understand this. So this engine is actually hanging on the APB bus. Okay, so strictly speaking, you have to take a look into the block diagram here. Here it is, okay, EXTI. So that's why it drives the clock from P clock 2, that is APB clock 2. Alright, so now if you look at this diagram very carefully, this engine finally connected to the NVIC. They are saying that it is going to NVIC, to NVIC interrupt controller. So NVIC is actually part of the processor, isn't it? So that means this engine is giving its 23 lines. So this is 23 lines to the NVIC. That means this engine itself captured 23 different positions of the NVIC. So that means 23 different IRQ numbers, isn't it? So that means we have to see now in the vector table whether these 23 entries are there or not. Now let me take you to the vector table. Here's the vector table, and if you search in the acronym table, you should find 23 entries related to EXTI block. So just search that. So here it is. So this is EXTI 0 line 1, 2, 3, 4. So like that you should find 23, isn't it? So let's see whether it is there or not. So here it is 5, right? Okay, we have to search 18 more. Here it is 9 to 5. So that means 5. So that means EXTI 5 to 9 lines are issuing interrupt on the same IRQ number 23. So that means totally 5 lines they don't have a separate IRQ number. Now we actually traced out 10 EXTI lines, right? Now we have to search for another 13. And here it is 10 to 15. Okay, another 5. So 15, still 8 are remaining. Okay, so here it is, Ethernet wake up through EXTI line. So we have to see how many such entries. So we have to trace 8 now. 1, here it is. So like that, if you search, you can trace out all 23 lines which are coming to NVIC. Here it is. Here it is. So that means the RTC issues its interrupt not directly to the NVIC, but the RTC peripheral issues its interrupt through the EXTI controller, what we just saw. It issues on IRQ3. So here they have mentioned that RTC wake up interrupt. So that means RTC's wake up interrupt comes over EXT line. RTC's wake up interrupt is not connected directly to the NVIC but through the EXTI line. So similarly, if you come down, you can see that, let me come down. Here you can see that USB's wake up signal or interrupt is not directly connected to the NVIC but through the EXTI line. So like that, EXTI helps to deliver different peripherals interrupt to the NVIC. Okay, so you may ask why the RTC interrupt is not directly connected to the NVIC, why it should go through this block over this line. I really don't know the answer for this. That may be due to some design issues, or handling through this EXTI controller is more beneficial, or it may add some advantages. So that's the reason they bring in this controller between some of the peripherals. So not all peripherals go through EXTI controller. Remember, EXTI controller has only 23 lines which is going to NVIC. For example, if I look at SPI go and directly touch the NVIC. You can see a SPI interrupt is directly connected to the NVIC. It's not through the EXTI line. So, but some peripherals, they deliver the interrupt to the processor via the EXTI controller block. Alright, great. So, but how about our GPIO? So, if you search this entire table, you don't find even the GPIO name mentioned in this column. Okay, so there is no GPIO mentioned. Then how does GPIO deliver its interrupt to the NVIC? Okay, the answer is through again the EXTI lines. So that we'll discuss in the next lecture.